reduce the block diagram shown in below. So we have to use the block diagram reduction technique. Here, first we have to reduce the innermost loop. Innermost loop, there are two innermost loops. So we have to consider one by one. If you consider this, we have to use the seventh rule to find the equivalent transfer function. That is, forward path is G1. This is equal to G1 divided by 1 plus Y plus, because it is negative feedback, G1 H1. Similarly, here also we can find the equivalent transfer function. Forward path is G2 divided by feedback path is H2. Loop transfer function is G2 H2. Negative feedback, that's why 1 plus G2 H2. This is H3. Now we have to redraw the circuit. Then this is G1 divided by 1 plus G1 H1. Second block is G2 upon 1 plus G2 H2. This is H3. Again, negative feedback. So the forward paths are these two. That's why we have to multiply these two. Again, we have to use fourth rule. Let us assume that this is G3, this is G4. Therefore, if we use this is equal to G3, this is equal to G4. Therefore, if we use the seventh rule, we'll get G3 G4 upon 1 plus Y plus, because negative feedback, G3 G4 H3. Now substitute G3 G4, G3 equal to G1 upon 1 plus G1 H1 multiplied by G2 upon 1 plus G1 H1 whole divided by, these two are in product, 1 plus G3. G3 equal to what? G1 upon 1 plus G1 H1, G2 upon 1 plus G1 H1. This can be taken LCM. That's why what we will get is G1 G2 upon 1 plus G1 H1 multiplied by 1 plus G1 H1 whole divided by 1 plus G1 H1 multiplied by 1 plus G1 H1. Instead of 1, we have to write this G1 G2. Here the feedback path is H3. G1 H3 is missed here. H3. That's all. Now whole divided by 1 plus G1 H1 1 plus G2 H2. This is numerator. This is denominator. Getting cancelled. This is equal to G1 G2 whole divided by 1 plus G1 H1. This is 1 plus G2 H2 plus G1 G2 H3. The same can be obtained by using Mason's gain formula also. Use the Mason's gain formula. What is the signal flow graph for this? Signal flow graph is this is node 1, node 2, node 3, node 4, 5, 6, 7. 7 nodes are there. 1, 2, this is 3, 4, 5, 6, 7. 7 is E of S. 1 is R of S. 1 to 2, nothing is there. That's why gain is 1. 2 to 3, nothing is there. Therefore, gain is 1. 3 to 4, G1. 4 to 5, nothing is there. 5 to 6, G2 is there. 6 to 7, nothing. Therefore, gain 1. 6 to 5, minus H2. Because negative feedback, that's why minus H2. 6 to 5. Minus H2. Similarly, 4 to 3 also minus H1. 4 to 3 minus H1. Then H3 is from 7 to 2. 7 to 2 is minus H3. This is the signal program. What is the formula? Mason's gain formula says T of S equal to 1 by delta sigma Pk delta K, where delta equal to 1 minus sum of gain products of individual loops plus sum of gain products of two non-touching loops minus sum of gain products of three non-touching loops plus etc. Here only 3 loops are there. All are 3 loops only. So up to 3 only, but all 3 are not non-touching. But 2 non-touching loops are there. This one, that is this loop and this loop are not touching each other. Therefore, this part is not there in the formula. Up to this, we have to find. PK means forward path. If you travel from RS to CS, only one forward path. 1, 2, 3, 4, 5, 6, 7. That's all. Therefore, K equal to 1 only. So P1 delta 1 we have to find. Forward path gain is G1, G2. That's all. G1, G2. Delta 1 is delta for the part of graph which is not touching the forward path. There is no graph which is not touching the forward path. Therefore, its value is 1. So P1 delta 1 equal to G1, G2. That's all. Now we have to find a delta. Delta equal to 1 minus sum of gain products of individual loops. This is loop 1, loop 1, loop 2. This is loop 3. Loop 3 is this is loop 3. This is loop 3. Now let us write sum of gain products of individual loops minus G1 H1 plus minus G2 H2 plus minus G1 G2 H3. This is over. Then this part is over. This part is over. This part is pending. Sum of gain products of two non-touching loops. These two are non-touching. Sum of gain products of two, only two non-touching, one pair only. Therefore, this is plus sum of gain products minus G1 H1 minus G2 H2. Therefore, plus G1 G2 H1 H2. That's all. That is delta. Therefore, transfer function T of S equal to numerator is only G1 G2, that is P1 delta 1 whole divided by delta we have to write. This becomes because of here minus, that's why becomes plus. This also becomes plus, this also becomes plus. Therefore, the delta is 1 plus G1H1 plus G2H2 plus G1G2H3 plus G1G2H1H2. So we have to check, we got earlier, this is the answer. Now this is the answer. Now this is the answer. We have to check both are equal or not. Numerator are equal. Denominator 1 plus. You have to multiply these two. If you multiply these two, what you will get? 1 plus G1H1 plus G2H2 plus G1G2H1H2. You will get. So let us check. Instead of this product, this we have to consider. This is 1 plus G1H1, G2H2, G1G2, H1H2. We got all the 4 terms. In addition, this term that is also there. Therefore, in both ways, we got the same answer.